Assalamualaikum. We are from Group 5. We will present about principle of linear impulse and momentum. Hi, there are 5 members of our group. The first one is Muhammad Razi Alha bin Faizalizam. The second one is Aminuddin bin Jamaluddin. Next, Muhammad Amin Rais bin Shahadan. Next, Siti Nur Ain binti Muhammad Jumain. And last one, Aslanul Husna binti Muhammad Asri. Hi, my name is Siti Nur Ain binti Muhammad Jumain, and I'm going to talk about introduction. The principle of linear impulse and momentum is obtained by integrating the equation of motion with respect to time. The equation of motion can be written as the equation below. Separating variables and integrating between the limit v equal v1 at t equal t1 and v equal v2 at t equal t2 result in this equation. This equation represents the principles of linear impulse and momentum. It relates the particle final velocity v2 and initial velocity v1 and the force acting at the particles as a function of time. The vector mv is called of the linear momentum, denoted as L. This vector has the same direction as v. The linear momentum vector has unit of kg/meter per second. Then the integrals integrate f dt is the linear impulse, denoted I. In this vector quantity measuring the effects of a force during its time interval of action I acts in the same direction fs and has unit of ns. The impulse may be determined by the direction integration. Graphically, it can be represented by the area under the force versus time curve. If f is a constant, then I equal f t2 minus t1. That's all for me. Thank you.
Now, I will present about the basic theory of principle of linear impulse and momentum. It describes how an object's momentum changes with applied force and moments. This is known as the principality of motion, the sum of external force acting on a body divided by its internal momentum. Recall from particle motion, the sum of external force acting on a body equals the rate of change of linear momentum of the center of mass. This is known as the principle of linear impulse and momentum. Any moving object can have momentum. Momentum is the mass in motion times its velocity. This means that if you increase an object's mass, you also increase its momentum. The same is true for velocity. Increase or decrease the object's speed and momentum by the same amount. But usually, the object's velocity changes instead of its mass, right? You may remember that a change in velocity means the object is accelerating, and acceleration is caused by force. Time counts when we are interested in how long the force acts. If you push a box across the floor for a few seconds, the time interval is very short. But if you make the box with the same force for several minutes, you've increased the amount of time it acts. The Greek letter delta means change in, and we read this equation as force time the time interval equals the change in mass time velocity. Be careful not to read this as force time time equal mass equals velocity, because now you are saying that impulse equals momentum. These are the example of the equation that we use in calculation. Now I will pass to the next presenter.
Assalamualaikum. My name is Muhammad Razi Alha, and I'm going to present about the equation and the calculation. For question 1, a 40-gram golf ball is hit over a time interval of 30 meters second by a driver. The ball lifts with a velocity of 35 meters per second at an angle of 40 degrees. Neglect the ball's wings while it is struck. Find the average impulsive force exerted on the ball and the momentum of the ball 1 second after it leaves the club face. For calculation 1, to find the average impulsive force, we are using the formula MVO plus sum of integrate F dt equal to MV1. Then we will get the answer, which is 467 Newton. Then to find the momentum, we will use the formula V into x equal to V1x equal to V1 cos 40. Then by simply solve the equation, we will get the answer, which is 1.18 kilogram meter per second.
For discussion, question 1, we are clearly informed that a 40-gram golf ball is hit over a time interval of 3 ms by a driver. The ball leaves with a velocity of 35 ms at an angle of 40. For the first question, we draw the momentum and impulsive diagram of the ball as it is struck. So basically, the impulse caused by the ball's weight and normal force N can be neglected because their magnitude are very small as compared to the impulse of the club. Since the initial velocity is 0, the impulse from driver must be in the direction of the final velocity. The question shows we need to apply the principle of impulse and momentum to determine the average impulsive force. First thing first, we all know that the principle of impulsive and momentum can be applied along the direction of motion. We have to use this formula mv0 plus t1 t0 f dt equal to mv1 to get the average impulsive force. The average impulsive force can be treated as a constant value over the duration of impact using v0 equal to 0. Then we need to convert 3 ms to 0.003 second and 40 gram to 0.04 kilogram. After that, the value that we have are inserted to the formula, and after do a calculation, we all can get the average impulsive force is 497 Newton. For the third question, we need to determine the velocity of the ball after 1 second using a kinematic relation, and then when we get a velocity, we can calculate the linear moment. For further explanation after impact, the ball acts as a projectile undergoing free flight motion. So, we must use the constant acceleration equation for projectile motion to get the answer. Lastly, based on this question, we know that we can apply this to our daily life as it is very closely related. With this calculation, we can estimate how far the golf ball can go, and it is very useful when we participate in tournament and so on.
For question 2, a 0.5 kilogram ball strike the rough ground and rebound with the velocity as shown in the picture. Neglect the ball's weight during the time its impact on the ground. Find the magnitude impulsive force exerted on the ball. For calculation 2, to find the magnitude of impulsive force, we will using the formula mv1 plus sum of integrate fdt equal to mv2. Then, by solving all the equation and insert all the information given, we will get the answer, which is 12.2 meter second.
For discussion question 2, we find out that a 0.5 kilogram ball strike the rough ground and rebound with the velocity shown. Neglects the ball weight during the time impacts the ground. From that question, we need to draw a momentum and impulsive diagram of the ball as it hits the surface. Here, V1 represent an initial velocity of 25 ms, having an angle of 45 degrees hits the surface and bounce back with an angle of 30 degrees with V2 representing a final velocity of 10 ms. Next, we need to apply the principle of impulsive and momentum to determine the impulsive force. For this question, we can use the same formula as the calculation one, so we can insert the information that we got from the question into the formula. The negative sign of V1 and V2 represent the direction of the velocity of ball in vertical direction is opposite to the direction impulsive force. After plugging the values in the relation, to find the magnitude of the impulse, we will use the relation I equals to square root I to x plus I to y. So we can get the magnitude. Seeing from this question, there are many new things that can we learn, such as anticipating time and direction. It has happened a lot in our universe, such as sport and so on. When it's happened in our environment, it can open our view of the principle of linear, impulsive and momentum. So it will make it easier for us to understand and apply it.
For question 3, the wheels of the 1,500 kg car generate a traction force described by the graph. Find the speed of the car when t equal to 6 seconds if the car starts from rest. For calculation 3, we are still using the formula mv1 plus sum of integrate f dt equal to mv2 to find the speed of the car. Then, by insert and solve the information given, we will get the answer, which is 20 meter per second.
For discussion calculation 3, it shows the wheels of a 1,500 kg car generate the attraction described by the graph. The first thing the question wants is a diagram of momentum and impulse. So that the car has mv1, which is the mass multiplied by the initial velocity, and act with w, f and n. And finally produce mv2, which is the mass multiplied by the final velocity. But in many cases, the normal force is only equals to the weight of the object, but that is only when the normal force is the only thing that resists the weight. That is not always true, and one should always be careful to calculate any force using Newton's second law. For second question, we need to find the speed using the principle of momentum. Earlier, on the main question has already stated to find the speed of the car when t equals to 6 seconds. If the car starts from the rest, so it will further facilitate our work. The principle of impulse and momentum can be applied along the direction of motion, so we can use more similar formula to the previous question. After entering all the values, we will get V2 equals to 20 ms, and that's the final speed of the car. This question is quite easy to solve because the info provided is enough for us to complete this compilation quickly. So, the important thing in answering our question is to find as much info or keyword for us to better understand the situation. Things like often happen to determine the principle of linear impulse and momentum effectiveness in the field of the car manufacturing technology. This is because everything related to dynamics is closely related to vehicle manufacturing, both in the air and on the road.
For question 4, The 40 kg crate is moving downward at 10 meter per second. The motor M pulls on the cable with a force of F, which has a magnitude that varies as shown on the graph. Find the speed of the crate when t equal to 6 seconds. Next, for calculation 4, to find the speed of the crate, first, we need to find the impulse due to cable force, and second, the impulse due to weight. The impulse due to cable force is 3600 Newton-second, and the impulse due to weight is negative 2354 Newton-second. After that, we will use the formula mv1 plus sum of integrate f dt equal to mv2 to find the speed of the crate. After that, the answer we will get is 21.15 meter per second.
For discussion calculation 4, from the figure provided, it shows a 40 kg box is moving downward at 10 ms. The motor M pull the cable with a force which has a varying magnitude as shown on the graph. Questions like this often came up when we answer exercise shared by lecturer, so they can be solved easily. To answer the first question, as usual, we need to draw a diagram of the impulse and momentum to sharpen our understanding. From the information that we get, the MV1 box is acting down. Next, the weight and force each act downward and upward and produce MV2. Furthermore, to solve the second question, we need to first find the impulse due to the cable force and the impulse due to the weight. After getting the second two value, we can only find the speed at 6 seconds. This question is often asked because the concept in this question is a concept applied in the construction site such as house and building. In fact, this concept is also used in the process elevator movement that we always use, so it is no problem for us to continue the study effectiveness of this concept for good technology in the future.
For the last question, which is question 5, two rails car with masses of MA equal to 20 mg and MB equal to 50 mg and velocities as shown in the figure. Find the speed of the car A after collision if the cars collide and rebound such as B move to the right with a speed of 2 meter per second. Also, find the average impulse force between the cars if the collision plays in 0.5 seconds.
For discussion calculation 5, the question state two rails car with mass MA equals to 20 mg and MB equals to 50 mg and velocity as shown. First, we need to find the speed a car A after the collision if the car collide and bounce so that B move to the right with speed 2 ms. Find also the average impulsive force between car if a collision occur in 0.5 seconds. From that question, we need to extract all the info and keyword so as not to make it difficult for us to solve this question. To find the speed of car A after colliding with car B, we need to use the conservation of linear momentum relationship as shown in the calculation path. After entering all the values, we will able to know the speed of the car. With that speed value, we can create the next question where it asks to express the average impulsive force between car. So we have to apply impulsive and momentum formula, which is MA VA1 plus F dt equals to ma va2. After all that, we can get the average force to complete this calculation. So the concept in this question also often happen in our country. In fact, everything that happen is very closely related to the principle impulsiveness and linear momentum. Only we rarely explore about this sign. So, as human beings, we should always explore new knowledge for the good of us and this world.
For calculation 5, which is the last one, first we need to find the conservation of linear momentum in x direction to find the speed of the car A. We are using the formula MA in bracket VA1 plus MB in bracket VB1 equal to MA in bracket VA2 plus MB in bracket VB2. Then, by simply insert all the information and solve it, we will get the answer, which is 0.375 meter per second. Next, to find the impulsive force, we will using the formula MA in bracket VA1 plus integrate FDT equal to MA VA2 in bracket. So, by using the answer from VA2 and we solve it, after that we will get the answer, which is 105 kilonewton.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Rais. Now I'm going to continue our group presentation for the conclusion. The principle of impulse and momentum describe how an object, linear and angular momentum, change with applied force and moment. It is known as the principle of linear impulse and momentum. Momentum is important in physics because it describes the relationship between speed, mass and direction. It also describes the force needed to stop the object and to keep them in motion. It applies to both particle motion and rigid body motion. The momentum of a body should not be confused with its kinetic energy. The distinction between them can be seen in the action of pi driver. Because of the impulse momentum theorem, we can make a direction connection between how a force acts on an object over time and the motion of the object. One of the reasons why impulse is important and useful is that in the real world, forces are often not constant. A force acting for a given amount of time will change an object momentum. Put another way, of an unbalanced force always accelerates an object, either speeding it up or slowing it down. If the force acts opposite the object motion, it slows the object down. If a force acts the same way direction as the object motion, then the force speeds the object up. Either way, a force will change the velocity of an object, and if the velocity of the object changes, then the momentum of the object also changes. This concept are merely an outgrowth of Newton's second law, as discussed in an earlier unit, Newton's second law. We state the acceleration of an object is directly proportional to the net force acting up the object and inversely proportional to the mass of the object. When combined, the definition of acceleration A equals change in velocity over time. The following equalities we get the result.